In this lesson, we're going to continue our work with series. We're going to focus on these two new formulas for arithmetic and geometric series. So arithmetic, you have this formula below, which will represent the sum of a certain number of terms in an arithmetic series. This formula is not given to you on your reference sheet, so you would need to memorize it, versus the geometric formula. This is given to you on your reference sheet. So basically, these two formulas add up the number of terms in a arithmetic or geometric series, similar to a summation. A summation will add up terms in any type of series. These two only work for arithmetic, meaning when you're adding a certain number to each term, or geometric when you're multiplying a number to get to each term. So I could rewrite or I could use summation still. So that's the key takeaway here is these are just two special cases, or these are formulas that work for two special cases, arithmetic series and geometric series. Summations work for everything. So summations would still work for these. The difference is I would use, so like for example, with arithmetic, if I wanted to write this using a summation instead of this new formula, what I would do to use sigma is I would use my sigma, and then I would have to, my rule would be my arithmetic sequence formula. So it would be the A1 plus N minus 1 times D. This would all go in for the rule. And then we would have N starting at 1 and then ending at whatever the number of terms are. If I wanted to use the summation formula for geometric, so basically again, it's going to yield the same result as this geometric series formula, I could use my sigma, and then for the rule to get each term, it would be A times R to the N minus 1. I'm going to actually put this in a square bracket so it looks like it goes together here. And then my starting term, my first term, and then whatever number of terms I have or wherever I'm ending. So these formulas are equivalent. The summation of a geometric sequence, so meaning you're adding up the geometric sequence terms, creating a series, is the same thing as using the sum formula for geometric series. Same thing for arithmetic. Okay, so that's the most important thing here, is to know that you do have a choice whenever you're finding the sum. So if you look at this first problem here, it says you can decide to use the formula or the sigma. So this is the sigma notation. Remember that big symbol there means sigma. So when I say summation or the sigma notation, that's the same thing. For finding the sum. So you can decide which one you want to use. Do you want to use the formula from the reference sheet or the one that you have to memorize, or do you want to use the sigma? Now here's the thing, you have to know all of these options, because there's going to be times where summations or the sigma won't work. Basically, when we get to the next page, you're going to see an example where you won't be able to use the summation. So for now, if you're finding the sum, then you can use either. You can decide. So let's just look at these couple problems here. So it says, is the following series arithmetic or geometric? Well, the first thing I want to look at is how do I get to each term? So I'm adding 1 to get to each term. So that's why it's arithmetic. The common difference here is equal to 1. You're adding 1 each time. Since it says to find the sum of the series, that means I can decide, do I want to use the summation notation, the sigma, or do I want to use the formula? So if I were to use the formula, let's go back up top here and just look at it. So here's my formula. N stands for the number of terms. I have to know the first term. Okay, great. I know 1. The last term, or in this case, however many terms I'm trying to find. So I would have to know that term number, and then I'm going to divide it by 2. So the very first thing I have to know is, well, how many terms are in this series? Because I want to find the sum of the series, meaning I want to find the sum of all of these terms. So how many terms are in the series? Let's just figure that out. So the number of terms is the n value. Now, you might be able to just look at this one and know what the number of terms are because it starts at 100 and it goes up by 1, or it starts at 1, it's going up by 1, and it's going up to 100. But let's say you couldn't figure it out just by looking at it. You know that this is generated by an arithmetic sequence. The pattern is an arithmetic sequence. So if I use the arithmetic sequence formula, what I can do is I can plug in everything I know. So let's say this last term, this a sub n term is 100. I want to know, well, what's that n value is what I'm going to solve for. So I'm going to plug in 100 for a sub n. That's my last term that I'm looking at. I want to know what position is that in. My first term is 1. I don't know what position it's in. I don't know what n is when I'm at my last term here. The common difference is 1. So now if we just solve this formula, so I have 100 equals 1 plus basically n minus 1. I can just drop those parentheses. I get 100 equals n. So what that means is the 100th term is actually 100. So that means that there's 100 terms in this um, series. So the number of terms is 100. So now what you see below here is see how this is really the summation of S sub 100, so of the first 100 terms. So 100 in for n plus 1 plus, so this is a sub 1, this is a sub 100. So I'm going to just write that. I'm going to say that that's a sub 100 since we know that the last term is really the 100th term equals 100. So I plug that in and I get out the 5050. So that's using the formula. Using sigma, well, you would have to do your arithmetic sequence formula. So you're going to do the summation from the first term to the 100th term, the last term. I have to know again how many terms are there, 100 terms. So then I just use my sigma formula. So I have, or my arithmetic sequence formula. So first term plus n minus 1 times the common difference. You could actually go through and do this by hand, but this is where it's useful to use that calculator button. So remember in the calculator, click it's called the function button, but it basically kind of looks like something like this. So if you use that, it has like a couple boxes on it. I don't have a calculator in front of me, but if you use that button, that gives you the sigma. So you should be able to enter that right in your calculator. I wouldn't recommend doing this one by hand because there's so many terms and you get the same answer. If we look at number 2, same type of question. Is the following series arithmetic or geometric? Well, when I look at the pattern here, I'm seeing that it's times 3. So this is geometric. My common ratio is 3. So let's do this both ways. Let's figure out using the formula. Let's figure this out using the sigma notation. So regardless, if I want to, either way I do this, I have to know how many terms are in this series because I can't count them. So my first step is going to figure out the number of terms. And again, since this is a geometric pattern, I can use my geometric sequence formula to figure out the number of terms. So kind of just pretend that the pluses aren't there. So if I use my geometric formula, so remember it's a sub n equals a1 times r to the n minus 1. So if I say, okay, this is my a sub n, that's the term I'm trying to figure out what position it's in. So that's going to be my 4374 equals the first term times the common ratio, and then n minus 1. I don't know what n is. That's what I'm trying to solve. I'm trying to figure out what is n when we're at 4,374. So now what I'm going to do is divide both sides by 6. So I get 729 equals 3 times n minus to the n minus 1. And then from there, now what we're going to do is we have to get common bases to be able to set my exponents equal. So how can I raise 3 to some power and get 729? Well, it's going to be 3 to the 6th power. You could also take logs here to solve this instead of common bases. That would work as well. So I have 6 equals n minus 1. If the bases are equal, well, then so are the exponents. I solve that, I get n equals 7. So that means that there's 7 terms in this series. So now I can do this using the formula or using sigma. So if I want to use the formula, let's try that way. So going up top here, using this formula that's given to me, let me write it down first. So I'm trying to find the sum of the 7 terms in this series. So the sum of the 7 terms, so A1 is going to be 6 minus A1 times my common ratio, which is 3 to the nth power. So that's going to be 7 all over 1 minus my common ratio. And plug in all of this, I end up with negative 13,116 over negative 2. That results in 6,558. And now if I want to try that using my sigma notation, so using sigma or the summation, this would mean I am going to start at 1. I'm going to end at 7 for the 7 terms. And I'm going to use my geometric sequence formula. So remember geometric sequence formula, or kind of using this right here. I'm going to have my first term. So 6 times the common ratio to the n minus 1, basically exactly what I have over here. This, again, I could do by hand. It would be manageable by hand because I have from 1 to 7. But I'm just going to type into my calculator, and when I did that, I got 6,558. Again, same answer, different way of getting there. You have the option to pick which way you prefer. You don't have to do both methods. It's whatever one you prefer. If we look at number 3, I just want to point out about this one, it's the same idea. So given the series, we look at this, and I see that basically I'm adding 5 each time. So I know right away that this is arithmetic. We're adding 5 each time. And we want to figure out what would be most efficient. And this says to find the partial sum, which means this is an infinite series. See how there's the dot, dot, dot? It's going to keep going. We want to find the first 30 terms. So this is telling you what n has to equal. You don't have to figure out what n is. You can't figure out what n is because it goes on forever. So instead, you're figuring out the first 30 terms. You could decide which one you want to use. Do I want to use the sigma or do I want to use the formula? So you can kind of see here the difference. If I want to use the formula, it's not wrong to do that. It's just not as efficient here because in order to use the formula, you would have to know a sub 30. So basically, you would have to figure out, use your arithmetic sequence formula to figure out the 30th term, and then you would plug it in. So it would just be 2 steps versus if you use your summation, well, you could go right into, here's my arithmetic sequence, and find the sum of the first 30 terms. Either way, you'd get the same answer. It's just using the sigma in this problem would be a little bit more efficient. So that's the new idea here with the series is it's the same thing as a summation. Sometimes it won't make a difference. It's your preference. Number 3, okay, it's a little bit more efficient to use the summation, but it really doesn't matter. It's whatever you prefer. When you go to the next page, though, if you look at number 4, this one, you're given the sum. So this says on your paper, given the sum, you need to use the formula. So if you're given the sum, trying to use a sigma is going to be too difficult. So you're not going to do that. You're going to use the formula. So whenever you're given the sum, you're going to use the formula. If you're trying to find the sum, you can choose which way you want to do it. Do you want to use sigma or do you want to use the formula? Um, and then in this particular one, so if I'm using the formula, you can see all I'm doing is plugging in my information. Okay, so I figure out that it's geometric. We're multiplying by 5. I plug in all of my variables. I plug in the sum this time, and now you're just solving this equation using skills that we've done in the past. So just be aware. You have options. If you're trying to find the sum, though, you need to use the formula. So I think the rest of the problems you should be set with, kind of keeping that in mind. You have some application problems here, but just, think about, should I use a sigma? Should I use the formula? Which one's more convenient for me? If you're trying to find the number of terms, if you're given the sum, then you definitely want to use the formula. And always think, is this geometric? Is this arithmetic? Think about how these word problems can relate to a series. So go ahead, finish up the notes, and then work on the homework problems.